Hello, MK. We are wondering if you're there yet. It is Thursday.
She's only 4 hours into the
Are
drive.
they actually going today? They didn't go like last night.
No,
All right.
they woke up at
So
5:30.
now I
Happy
know.
travels.
All right.
MK's come across a Sharknado.
Is this in the way?
Take pictures.
No, we're good.
All right. So here we are, Brian, with the null hypothesis. We're picking up where we left with the stream data. We got it all in our calculators. It's on the back of day 5. So you started putting it in yesterday.
Okay,
And
I'm gonna
we
zoom
are
up.
finishing, we got it in, and now we can use the data on one variable statistics. We found X bar from our data as 4.77. We noticed that we put the data in and looked at a histogram. There was no outliers or strong skewness, and the probability plot was nearly straight.
Are you good?
So,
I'm good.
RIN, we were
Ren is
there.
good.
When we looked for independence, 15 times 10 was 150, and we assumed there was 150 aquatic spots, so we went with it. So,
Assume.
we're doing the T statistic. 4.77 is X bar. And Brian, looking at this, can you tell me what you know? 5, right. Looks like it's going to be negatory.
So
So?
the hypotheses are that aquatic life becomes at risk at
Yeah.
around 5 milligrams per liter of dissolved oxygen, whatever. And we're saying, well, if it happens to be that these locations have a mean below 5,
Then we're upset.
then we're like, hey, I don't know if that means really true.
Right.
Alright.
Okay, so what about goes on the bottom? MD, we need the rest of the test statistic.
standard deviation over the square root of n.
What
So
is S of X then?
I just deleted it.
0.9396.
0.939, yeah, that's what I thought.
Divided by the square root of n, which
Square root
is
of 15.
Alright, tippy top. Anyone get it?
Alright, negative 0.95.
Alright, negative 0.95. I know it's negative. So go to chart B or your calculator. You get the choice. The DF is 14. Alright, so we're going to look that up and get
Oh wait,
the
14?
p-value. So you can use chart B or you can put it in your calculator. It was under second vars and a TCDF, and you can plug in the lowest value is, alright, so we're going this way on this one. So 0, here's negative 1, we're at negative 0.95, about right there. So we have to tell the calculator the lowest value first. So that's going to be like minus 100, since this goes on forever. But we'll stop at minus 100 if it'll take a number that large. And then we're going to go up to negative, this is the highest value, and then the degrees of freedom are 14. So if you're using your calculator, second vars, T, CDF, and these are the numbers you have to give it.
Wait, so it's not the lower,
It always starts with the lower.
but isn't the lower 0.9 negative 0.95?
Yeah, because you're going
Yeah,
less
because
than.
see, on this part, we're going down from negative 0.95. So
Do you-
negative 0.95 is the highest value.
Can you figure that out because HA is less than 5? Is that how you know
Yeah.
which way it's going? Okay.
Yeah.
Just how do you not put the negative negative sign in?
If you're using the chart, you ignore the negative
No,
sign.
but in the calculator, because when I put the negative in there, it says an error.
It does.
Yeah.
What? Okay. Let's see.
Talking
if
about?
that's true. All right. Let me see if mine does the same.
Like, what's the answer?
Second
I'll
bars.
tell you if it's.
I got it right.
I got point.
I did negative. Did you do negative 100, negative 0.95,
Did you
and then
put
14?
the correct negative sign in? It
Yeah.
has to be that funny little negative sign. You know what I mean?
So you put negative 100 as the minimum.
Yeah.
And then negative 0.05 is the upper, negative 0.95. And then
So when we get the
14.
p-values through doing it mathematically, we get 0.15. There's between a 0.15 and a 0.2 chance that this hypothesis is wrong, or that we get
Get that.
we get
It's fine.
A
sample.
from a sample that far away.
I
So
swear
we
it
get
didn't work a minute
4.77
ago.
sample that far away, which is a fairly good chance.
What'd you get for your p-value?
0.179.
0.179, the
Which
calculator
is-
said point.
And
Did you ever
then-
get it out of your calculator?
I did.
What was wrong?
I don't know.
Alright.
It worked the same.
Point
And
one
then
seven nine.
I did the chart
chart.
B and it was 0.15 and 0.02.
Okay.
0.2, not 0.02.
Alright.
So that's right.
Alright, so they
So it's
concur.
greater than 0.05,
Right.
See, this is what you do.
which means you
You got this,
fail to
MK?
reject, right?
You got
That's
this.
the CDF and what time for 100 and 14.
Here's what it looks
yes.
like on my paper.
Well, except 100 first because. 100
Yeah,
is
thank
still-
you.
It's so far away. Hold on, I'm gonna zoom out. Okay, there we go. There we go. If you want to see that, good math. There's the answer.
Why is it the lower?
Mine lists it maybe different in numbers. Mine lists lower and then up. So negative 100 is the lower and negative 0.95 is the
The
upper.
p-values from the chart came out to be between 0.15 and 0.20. The calculator 0.18, which is right in that interval. So we're comparing that against 0.05. So this is quite a bit larger than 0.05.
Does that
So
mean you
therefore,
fail to
this could
It's
happen.
the same number except positive.
reject?
So we're not going to reject this. We are going to fail to reject it. Does that make sense? Fail to reject. So therefore, we cannot reject this. So from the sample we took, we are saying that the aquatic life is okay. At least from this one sample test.
So how do you write that in context? You failed to reject the
Yeah, well, I guess.
claim that the wildlife is less than 5.
Right. So So we cannot assume that the aquatic life is in risk, is at risk. We cannot assume that. Because we would if we could have rejected it, but our results did not lead us to reject. We failed to reject.
Fail.
Wait, so
Okay.
part B and it says what kind of
This is
mistake?
really fun.
All right,
I really
another
love
part
this.
says what type error. It's always gonna, if you fail to reject, it's gotta be a type 2. So it depends on what your conclusion was. When you fail to reject, that's a type 2. And if you reject, you have a possibility of a type 1. So that's that. All right, we finished that, and I would like to go on and do one more example because it's two-sided and it's mini-tab. So, show this to MK.
Juicy pineapple.
All right, this is still day 5. It's just our